Over to you, Juliet.
Great, thank you, Dr. Seun Kolade. So welcome to the African Entrepreneurship and Innovation webinar series. My name is Dr. Juliet Bano-Yakubu. I am a lecturer in business and management at the Montfort University. And like Dr. Kolade already said, I'll be your moderator for this session. So the African Entrepreneurship Cluster is a research cluster within the Center for Enterprise and Innovation at the Montfort University, and it works with a vast network of international scholars, industry, policymakers across about more than 20 African countries. Of course, in order to be able to produce and share knowledge to advance transformative social value through entrepreneurship and innovation. So our research is published in leading peer-reviewed academic journals, of course, as well as books and official reports. So this event is brought to you by the African Entrepreneurship Cluster, and this is one of a series of events that we organize. So today, our guest speaker for this session is Dr. Samson Oloketuyi of Yaba College of Technology, as we look at the topic of 3D printing and the future of manufacturing in Africa. And Dr. Seun Kolade, who would also share insights from his recent research in this area. So Dr. Samson Oloketuyi is an experienced lecturer with high skills in engineering, research and development. And his research interests are in computer-aided design, additive manufacturing and renewable energy. And he holds a Bachelor of Engineering degree in mechanical engineering from the University of Benin, in Nigeria. He also holds a master's degree in chemical engineering from the University of Lagos and a PhD in technology from the University of Ibadan. And his current research focuses on the analysis of additive manufacturing, which is also known as 3D printing, and computer-aided design in prototyping of devices and machine parts. He is the director of the academic planning at Yaba College of Technology, which is in Lagos, Nigeria. So thank you very much for joining us today, Dr. Oloketuyi. Our internal speaker is Dr. Seun Kolade, and he's an associate professor in entrepreneurship and international development at the Montfort University. And he also leads the African Entrepreneurship Cluster. And his research activities cover, a broad area of digital transformation, transformative entrepreneuring, social and spiritual capital, refugee entrepreneurship, and SME strategies in turbulent environments. And he's a senior fellow of the Higher Education Academy, and of course, a certified management and business educator. And he has more than 60 academic outputs, of course, including journal articles, book chapters, and conference papers. So today, you see, we have a vast amount of experience to be able to tap into, especially on the topic of 3D printing in Africa. So a huge welcome to you both. Before we begin the session, if you have any questions, please put them in the chat as the discussions are going on. Also, please bear with us. There's a network lag, so bear with us as the presentation is going on. So I'll give the floor back to Dr. Samson Oloketuyi to start us off, and I hope we have a very insightful discussion. Can you hear me, Dr. Oloketuyi?
Yes, I can hear you. I want to get my screen on.
Okay.
Sorry, a moment. Good afternoon, the chairman of this session, the co-speaker, Dr. Seun Kolade, the moderator, and the participants from different parts of the world. I say good day to you all. The title of my presentation is 3D Printing and the Future of Manufacturing in Africa. As it has been introduced, I am the current Academic Planning Director of Yaba College of Technology, Yaba, Lagos, Nigeria. I'm a chief lecturer in the School of Engineering, Yaba College of Technology. 3D printing is a new disruptive manufacturing technology, otherwise known as additive manufacturing. It is a technology that converts a digital file of a 3D drawing to solid object by deposition of printing materials layer after layer on a print platform until the entire solid object is produced. I would like to state the processes involved. The 3D CAD software such as SolidWorks or Fusion 360 or AutoCAD generates the 3D model of the substance to be produced as solid form. The file that is drawn from the 3D software is saved in STL format. STL means Standard Triangle Language, and this is a mapping process. STL file is taken to another software called the slicing software. This software generates G-code file. This G-code is a programming language for CNC machine, which is a computer numerical control machine language. The G-code file is copied into the 3D printer before it starts printing. The 3D code's purpose is to programmatically move the print head as it deposits material layer after layer on the print platform of the machine. There are different technologies used in 3D printing. I'm going to highlight the three most common technology. The first one is material extrusion. The second one is vast polymerization, while the third technology is bed fusion. Under material extrusion, we have field deposition modeling, FMD, which is very common. The 3D bioprinting is also a common printing technology. This is used in medical field, while the other one is construction 3D printing. This is the 3D printer that is used to print houses by civil engineering construction companies. Then we have another technology that is used in 3D printing, which is vast polymerization. Vast polymerization operates in liquid medium, and the liquid medium that is generally used is a resin. It's a photopolymer plastic that converts from liquid stage to solid state under the influence of ultraviolet light. The three types highlighted in this presentation are: one, stereolithography apparatus, SLA, digital light processing, printers. Also, the third category is powder bed fusion. This one is used to print heavy metals, metal with high melting points. The three types under this section is selective laser sintering, SLS, laser powder beds, FLP, BF, selective laser melting, SLM. Is a it operates in a solid medium. Printing materials, there are different printing materials available. We have thermoplastic. Under thermoplastic, we have what is generally referred to as ABS, acrylonitrile butadiene styrene. We have PLA, polylactic acid. This is a biodegradable plastic. Then we have photopolymer resin. Then under metal powder, metals are prepared in powder form for this type of printer. We have metals like copper, we have steel and aluminum. Organic or biological material used for this. This is a 3D printer used in a medical field, and the material for printing are living cells and nutrients. Also, we have concrete for prototype houses. Concrete is a printing material under 3D printer of that category. From statistics and from literature review, the contribution of Africa to manufacturing is grossly very low, and it's about 1.9. This information obtained from industrialized Africa, compared with what is happening in the other parts of the world. 1.9 is small, and the need to increase this percentage is one of the objectives of the presentation today. Also, from literature review, also the value of 3D printing as at 2020 was 13.78 billion US dollars, and the expectation is that annual growth rate of this capital is about 21%, and by 2028 it will be about 62.79 billion US dollars, according to Kolade, Adegbile, and Strapon 2022 publication on 3D printing. 3D printing is a new technology driven the fourth generation revolution. It has the capacity to leapfrog African countries in technological development if the economic advantage are properly harnessed to form many micro and macro enterprises in rural and urban areas. Well, here I want to highlight the advantages of 3D printing. 3D printing is additive manufacturing processes, and the traditional manufacturing method that is known to almost everybody is called suppurative manufacturing. And to set up industry that uses suppurative manufacturing requires huge amount of money or a huge amount of capital. But in additive manufacturing, the required capital to set it up is small. So as we go through the advantages, we see some of the reasons why one is correct to say that 3D printing can actually leapfrog African countries to high-tech level. One, it reduces material waste in comparison with suppurative manufacturing method, traditional method of manufacturing. Two, low investment in inventory. Only material that are needed for specific job are stored in 3D printing industry. Waste management is minimum because the material is added as it builds the solid objects. There is little or no waste produced from the machine. So the cost of managing the waste is not part of the project. It allows rapid prototyping of new products to reduce time and cost. Yes. In the other method of manufacturing, a lot of expertise are required in tooling or in setting up the jigs and the rigs for prototyping before the actual product is produced. It allows products to be produced closer to end users. As a result, shipping cost is minimum as far as 3D printing is concerned. It requires small capital investment and space to set up additive manufacturing industry. Low capital investments is required in acquiring 3D printing machine in comparison with traditional manufacturing machine. Low power consumption. The energy required by 3D printers is small, so energy can be from renewable source, e.g. solar energy, especially in rural areas. It is easy to accept 3D printing in Africa, which is technically underdeveloped than the developed countries because of huge capital investments in the traditional method of manufacturing. This is ideal technology for Africa because it doesn't require much capital input to set up a 3D printing farm or 3D printing shop. Experience in the old technology is not useful because it's a new technology. 3D printing does not need central high volume production. Small and more sustainable businesses are possible through 3D printing technology, as earlier explained. So 3D printing current development in some African countries. Many African countries are still lagging behind creating proper awareness concerning 3D printing, otherwise known as additive manufacturing, due to political or economic factors. However, other countries have started setting up structures for proper takeoff of the technology. In Kenya, academic institutions, industries, and government are engaged in promoting 3D printing, manufacturing research and development, according to Kolade, Adegbile, and Sapron research work of 2022. South Africa government is also playing leading roles, engaging the academic institutions and industries in 3D printing research and development. The North African countries, Morocco, Egypt, and Algeria, have tremendous advancement in 3D printing research and development more than their counterparts in other parts of Africa. They get regulatory support from their various governments to produce custom prosthetic implants, dental aids, and other materials from kenresearch.com. Sub-Saharan African countries such as Nigeria, Senegal are still in the early stage of accepting 3D printing technology. No special pronouncements have been made by the various countries' governments to evolve policies in favor of 3D printing. Only private organizations in this country are still making impacts in their small ways. Strategy to drive 3D printing innovation and entrepreneurship in Africa. There must be synergy among academic institutions, governments, and industry to actually make 3D printing to strive very well in Africa. The government roles are: one, they must create the enabling environment by reducing taxes on 3D printing components, by evolving a good education policy, and by granting loan for research and development. Infrastructures should also be in place, like constant supply of electricity. You know, in Africa, we have electric power supply, and 3D printing has an insane printing hour that require electricity. Information and telecommunication technology is also very important for 3D printing industry to prosper in Africa. Provision of loan for micro, small, and medium 3D printing enterprises is also very important. Academic institution roles, yes. Africa is endowed with natural resources. Researches are still going on in 3D printing to get new materials that may probably increase the efficiency of the system. And Africa has enough raw material to carry out this research. This is the responsibility of academic institutions. Development of curriculum for 3D printing which will dovetail into existing courses in art, science, and engineering is also very, very important. Provision of different manpower for development of 3D printing at different levels of education. Equipment researchers are needed because we must not only be using the 3D printer, we must go to the next level of producing printers ourselves from the different resources that we have. Material researchers, product design, craftsmen are also required. Academic institution, the university and other tertiary institutions to have innovation hubs where research accomplishments in 3D can be tested for commercialization before deploying them to the industry. They must seek for grants to develop more efficient 3D printing processes and materials, especially for non-biodegradable waste plastic products and electronic products littering streets in Africa. Industry roles, the industry must be readily be on grants to accept research outputs so that industry can be built from research outputs to increase the GDP of the various countries in Africa. The industry must be ready to carry out research finding to commercialization level. And also, they must be ready to provide grants for further research. So businesses that can come up from 3D printing, product customization business can be from 3D printing, promotional products for advert agency can also be produced with 3D printing technology. Spare parts for old machines that have been abandoned due to lack of spare parts. Probably the manufacturers are no more producing such model. 3D printer will solve such problems. Medical implants production is also very possible. Artificial limbs, artificial teeth, or anything artificial that can make life sustainable is possible through 3D printing. Prosthetic development and production items such as artificial limbs, teeth are customized for users. There is no problem of one undersizing or oversizing the end user because the product can be produced based on specification. Electronic assembly product production can also be from 3D printing technology. Fashionable products production customized for celebrities, glasses frames can be produced. Artifacts that have been produced for many years with probably wood, stone can be reproduced with plastic and some other materials for tourism and even to serve as souvenir to tourists, to different tourist centers we have in Africa. Toys and figurine production is also possible through 3D printing. Jewelry, customized jewelry production, engineering product development, rapid product prototyping center is also possible to set such outfits to help create employment opportunities for engineers and scientists. Architectural model development center is also possible. People in architecture to design houses and get the 3D model of the house for better presentation to the clients. Home decor products development center can also come up from 3D printing. CAD through 3D printing training center can also come up from 3D printing technology. So the list is endless as far as businesses that can be generated from 3D printing technology. Conclusion, 3D products are novel products. They are attractive to consumers. They are excellent. They are excellent for business. Sorry. 3D products are novel products. They are attractive to consumer. They are excellent for business because they waste less and use less materials. In addition, they weigh less and cost less to ship. Thank you very much. That is the end of my presentation. Thank you.
Great. Thank you very much, Dr. Oloketuyi. That was very informative, and I did learn a few things. So I'll then go back to Dr. Kolade, if you want to tell us a little bit more about your research.
Okay, thank you very much. Have you stopped sharing, Dr. Oloketuyi? You can stop sharing now. Thank you for a very
Yes.
I think you are still sharing. Yeah, I think
yes.
you have to stop sharing.
Except you want to share my products produced with 3D data.
Well, I think you're still sharing.
Yes, if you allow me, maybe I should go to my file.
No, you can. Okay, yeah, that's great, fantastic. All right, so so thank you once again, everyone, for attending this session. I wouldn't want to repeat what Dr. Oloketuyi has said. Thank you for that, and I'm sure the slides will be made available on request. So I just want to add a few key things. So I don't have a slide for this. This is just really a few key comments to just buttress and add to what Dr. Oloketuyi has said. I've been researching 3D printing for the past few years. As you notice also, one of our articles was cited in Dr. Oloketuyi's presentation. So I just want to make three or a few key comments. The first one is about, the economy or the logic of 3D printing. I mean, we all know that, traditional manufacturing, which has been also described as subtractive manufacturing, works mainly by the logic of economy of scale, right? So, and that is, the manufacturers are usually big corporations who are to produce en masse in order to realize, or to achieve the profit that they need, from this manufacturing enterprise. Okay, so one of the disruptive features of 3D printing is that it does not require the economy of scale to work. Okay, so you don't need mass production in order to make profit. So 3D printing works mainly and essentially by what is called the economy of one. That is, it is possible for you to make enough profit by just producing at a very small quantity. And in addition to that is then the idea of customization. So one of the things that the Industrial Revolution and the age of mass production brought is then the lack of opportunities for customized products, because everyone you have millions of a particular products produced to a particular standard, and so there's not a lot of room for customization. So one of the key advantages again of 3D printing is the opportunity for creative customization. So you can create a wide range of customized products from 3D printing. And of course, in addition to that, is there's no more need for customized high volume production and large inventory stocking. So I think that was also alluded to, which is a disruptive, feature in terms of the traditional supply chain. So you don't need to have, large, stores in stock either as a producer or as a seller for that matter. But with regard to the African continent, we talk about leapfrogging, and in order to make sense, understand the idea of leapfrogging, we need to understand, the locking mechanism, the reason why, traditional manufacturing has persisted in many countries of the world, and why it will take, a disruptive force of a technology like 3D printing to break. And that is because there is huge investment. We also talk about this with regard to the circular economy, the linear economy versus circular economy. There is a lot of investment, sunk investment, it is called in economics. So that is millions and millions that have been invested in old technologies. And that is why in places like the United States, despite the merit of a new technology like 3D printing, it's still slower to take off, because there are millions and millions of sunk investments, in subtractive, old technology. But when you then think about it, that is where the advantage for Africa is strong, because compared to a place like the US or many of the other developed countries, we don't have the same level, not nearly the same level of sunk investment in new technologies. So we can begin, afresh. When you think this is exactly, what has happened with regard to the old telephone landline. Africa has been able to leapfrog in terms of penetration of use of smartphones and all of that. Whereas for developed countries, it was a kind of a transition first from landline to mobile phones and all of that. So there is an opportunity there in Africa in the sense that we haven't sunk a lot of capital in old technology. And we can begin actually from new ones because the locking mechanisms are much relatively easier to break. So, and I think, that is where, our work, our recent paper, which has been, which I'll happily share during the Q&A as well to you all, is open access. You can access it freely. As look into this, in great detail. But then we then realized that in order to make this happen, the countries that are beginning to make impact, like South Africa, you have a dynamic synergy between government, research institutions, and higher education sector and industry. You need this kind of dynamic synergy in order to generate and sustain new market for 3D printing products, in order to actually support, tax incentives and the rest of that for 3D product, but also to support, both the upstream and downstream of 3D printing, and then empower and enable small and micro enterprises, because 3D printing is the surest way to bring the African blacksmith back, with the swagger of digital technologies into the 21st century. Because it is best suited for that kind of, customized, small scale production that is actually profitable. And where, innovative producers and manufacturers and engineers can bring all their creativity to bear in actually. So so there's a prospect of actually returning to a place where in your locality, in your town, or wherever it is, there are pockets of 3D printer that you can just go and say, this is what I want. Can you make this? Can you make this jewelry for me? Or can you make this prosthetics, for me? And they will do it exactly to suit the particular customized case. That is, that is exciting. But in order to make that happen, you need that, synergy between, between government, between industry, and between higher education institution. So I'm going to just pause there. I will share the paper. We have case studies from South Africa, case study also from Kenya, which is beginning to initiate some kind of development in this area. But otherwise, I will stop there for now. I will hand over back to the moderator for Q&A, and look forward to comment and questions. And I'm sure Dr. Oloketuyi will be ready to respond to many of them as well. So thank you very much once again.
Yes. Thank you for that insightful speech and elaboration on 3D printing. Martins has added that, just to add that there are other benefits of AM technologies, part consolidation, lightweight structures, customization and personalization, use of multi-materials, etc., etc. So he's put his thoughts there. But there's a question from Femi Adedotan asking, how prepared are our educational curriculum in terms of proficiency in advanced engineering materials? I'm not sure if it will be Dr. Oloketuyi who will take this, or Dr. Kolade.
No, I think we should ask Dr. Oloketuyi, because it is right within the African higher education system. You can speak to that first. In the meantime, I will share the link to the article on the chat.
So Dr. Oloketuyi, Femi has asked, how prepared are our educational curriculum in terms of proficiency in advanced engineering materials?
Okay, thank you very much. If we look at our engineering curriculum, the engineering curriculum we use in Africa is rich but because of dynamism in technology, there is need to review some of the curricula to reflect what is happening in the present day world. I know that in engineering, we have material science. That curriculum is very fundamental to study materials because we need to understand materials from the build-up, the molecules and the atoms, how they are and how they interact with each other. Then they need to create curriculum that will enable students or scholars to know what to do in coming up with new materials based on the material in existence is very important. And I think educational institutions should put heads together to see how curriculum can be tailored to the aspirations and the needs based on the evolving technology that is coming up. Because I know it's a great challenge, like 3D printing of metals. During the literature review for this presentation, I read about the challenges that materials that are printed with a 3D printer, the challenges they have at the level of the crystallography structure, how the molecules are arranged, the problem of strain handling, the problem of grains not properly arranged, and these always have effects on the strength of the metal. I think our higher institutions, higher institution of learning, one of the things that we have to boost the research effort is our reading culture must increase. The reading culture of students must increase, and even the lecturers, their reading cultures must also increase so that they be able to have high delivery when it comes to teaching students on how things are to be done based on the prevailing situation we have in the world at present. So thank you very much.
Great. Thank you very much for answering the question for us. There's another question by Martins asking if it would be wrong to allude to the fact that there are systematic barriers to the adoption of AM technologies in sub-Saharan Africa. So if you could take that question.
I can. Oh, sorry. Are you?
Okay.
Yeah, Miss. Just one. I think there are systematic barriers, and that is part of what we've been talking about in terms of the lack of policy. So that is the first thing, really. You find that most of the African countries do not have enabling policies to support 3D printing on the continent. Is the only country we've seen that has made some progress in these areas, is South Africa and Rwanda. In the case of South Africa, they identify particular sectors of the country's economy that they sort of want to develop some kind of comparative advantage in, and the jewelry subsector, for example. So, but I think in order to make this work, you need an engagement, a policy kind of engagement from government to give support, to fund, research, but also you need, universities, that are attuned to this. Like we've talked about before, new curricula, new research projects in these areas that are in close alliance with industry. So I think there are systematic barriers. That is for sure. And I think because also, of course, the African countries are a bit more collectivist than individualistic. So you find that if there is a kind of a positive reception to technology, by leaders, both at governmental levels and other levels, you are going to see a higher rate of uptake than what we have at the moment. So because you also need to create that network effect. So that is one of the things you need to append, the lock-in to old technology. So you need more people doing it. You need, you need a 3D printing shop to proliferate in order to really realize the advantage. So yeah, so these are some of the systematic issues. But also one other thing that we find in the South African case is that there is a rapid prototyping, as they call themselves, rapid prototyping association of South Africa, RAPDASA. So all of those small and micro enterprises that are engaged in 3D printing activities have come together and formed a national association. And that is important because that is when collectively you can then begin to also influence policy. You can also begin to actually drive markets, and even consumer behavior as well. So yeah, I think there are systematic barriers without a doubt.
Great, thank you for that answer. I don't know if Dr. Oloketuyi would like to add to that as well. I think you're muted.
Sorry, the last speaker said most of the things I would have attempted to say. But the one major problem we have in sub-Saharan Africa, or let's say sub-Saharan Africa, is electricity supply. 3D printing, as I said in the presentation, has an insane long hour of production. And for 3D printer to work for a very long time, there must be constant supply of electricity. Electricity failure for some machines can cause a lot of damages to what one is producing. Like the 3D printer I have in the house, I made sure that I bought a UPS, even though I have inverter. And I made sure that I have at least three sources of power in case the general source of power fails. So there, because at times some printing may take about 50 hours. I think my longest period of printing maybe about 30 hours. It was a great task for me because of the epileptic supply of power. So that is my addition to what the last speaker has said. Thank you.
Great, thank you very much for your inputs. Does anybody have any further questions? You can unmute your mics and ask away. Or if you'd rather put them in the chat box as well, that's fine. Dr. Kolade, I think someone is asking if it's possible to have a recorded copy of this presentation.
Yes, so the session is being recorded, and we will certainly be happy to share the recording. Yeah, definitely.
Yeah. So the floor is open to any questions or comments as well.
So if anybody wants to make a comment on the floor, please feel free to do so as well. That is, if they want to speak to it rather than type a question in.
Good evening, sir. Engineer Doctor.
Good evening. Juliet, over to you. I think there's somebody is trying to speak.
Engineer Femi, Doctor online, sir.
Hi, Femi. Yes, we are listening. You can ask your question.
Well done for the lecture. I thank Dr. Oloketuyi for delivering this kind of lecture at this particular period. I just want to ask him that how prepared are our institutions concerning the study of advanced engineering material in handling 3D printing and AM. Can you get me, Ma?
Yes. So Dr. Oloketuyi, I don't know, or Sean, I don't know if you heard the question.
Dr. Oloketuyi?
Yes. I had the question. I think I've answered the question. That was the first question I answered. That actually we our institutions should be prepared for the new challenges in technology. And the preparatory thing that should be done is to change the curriculum to reflect what is involved. And the students must be ready to read according to what the curriculum is dictating. And the lecturers must also be able to do extra work to get information, because most of the things that probably the new curriculum will have probably be new, and without good reading culture, it should be very difficult for students and lecturers to be able to go along with whatever new technology is being introduced as a result of development in technology worldwide. But as far as for preparedness, it is a matter of determination to say that these new challenges must be overcome, and people preparing themselves to overcome it. Then, as I said in the first response, that the curriculum must be designed to reflect the technology that is existing, so that although the technology, like I said somewhere, that the fundamentals of some of these courses still remain the same. It is just the application. It's just like when you are studying new materials, you have to say something about the arrangement of the molecules, phase, body structure, and some other things that we learn in those days in material science. So I see no reason why our institutions should not be prepared to overhaul the curriculum to meet the aspiration of the new technology. Thank you.
Yeah, thank you very much. Yes.
Yeah, and I think if I may just add quickly to that, the key point there is overhauling the curriculum. Okay. And I think, and that is one other thing that, we cannot be locked in this model of trying to imitate what is being done in Western countries, because their priorities are different. I spoke earlier on about, sunk investment. So for the foreseeable future, the dominant, technology for manufacturing in the US is still going to be subtractive manufacturing because there's a heavy investment of capital in there. So we need to think, originally we need to think creatively. It doesn't mean thinking in isolation. We still, adapt ideas, but we have to adapt them to the particular situations in African countries. And a lot of that is also about curricular innovation, I don't see why there shouldn't be, undergraduate degrees in additive manufacturing by now in many African countries. I'm not aware of any country, in Africa that offers that, maybe South Africa. So those kind of thinking is what we need. Or in fact, executive training programs, for the industry leaders, in 3D printing, to upgrade and update them, short courses, that can actually bring those who are already actors in the area to speed. That is the sort of thinking that we need, and we cannot. African countries cannot be looking to the West for leadership in this kind of ideas. Yeah, I think somebody is raising their hand, Gillian.
Yes, but before that, I think Madiwa asked the question, and Madiwa is a level 300 student, and she would like for us to speak about large-scale 3D printing and its limitations for large-scale businesses, because she would like to get into 3D printing in the future.
Yeah, so I think 3D printing is a flexible technology. I would argue that it's better suited to small scale producers because of the economy of one, but it doesn't mean that large scale producers cannot get into it as well. Of course, there will be limitations in that regard, but let's not also forget that 3D printing technology is actually a family of technologies. Okay, and I think, Dr. Oloketuyi did justice to that earlier on, where he categorized them to three, and under the three, you have, actually specific types in each of those three categories as well. So I'm sure there's big space there for large-scale producers to also engage. But I think the point here is that the structural disadvantage that small manufacturers, micro-scale manufacturers face is almost removed or eliminated. So they can come actually in that space also and compete, which is not something you can say with the dominant traditional technology. I mean, the Industrial Revolution obliterated, the African blacksmith in one fell swoop, not only because of the sophistication of the technology, but because of the economy of scale. So, but now this technology is bringing those small scale producers back into play. It's great. So as a 300 level student, fantastic. Go for it. I would say, you're going to be one of those new generations of 3D enterprise owners that will encourage others, and the more there are, the better actually for small scale producers. So yeah, that's another thing which is good. Unlike maybe when you have large scale manufacturers, there's a sense of, kind of destructive competition sometimes, but in 3D printing, there's room for small scale producers because it is about your creativity, actually. It is about you are customizing, the product as well. And so there's a lot of room there, I would argue.
Great, yes. Indeed, there's nothing you can't achieve if you put your mind to it, so do go for it. Dr. Max DK, your hand is up.
Yeah, many thanks to Dr. Idowu for such a wonderful presentation. And I remember, when we were in the Gambia in October, this issue of, I remember you invited somebody to our discussion, one an entrepreneur there in the Gambia who could not attend eventually. But going in terms of what have been presented here already, first of all, we know the challenges of Africa, like Dr. Idowu pointed out, Sub-Saharan Africa in particular, the issue of money, and the Dr. Seun also pointing out here that huge outlays of money is very needed. Money must be investment must be made here, and so far from the sort of solutions to the challenges that have been pointed out is more of, to me, if you ask me, what you can see already is at the level of the institutions themselves, asking about, changing the curricula or introducing certain courses to the curricula, But then how do we get the government to be involved in things like this? Because you cannot solve this problem at the level of the academic institutions alone. I believe we need to get the government more involved. So it's like, my question is, how do we do this? Thank you.
Yeah, thank you very much. Maybe I can quickly speak to that and then let Dr. Oloketuyi then share specific experiences of what have you been doing? What is your success rate with the Lagos state government or with the Nigerian government? But I think, what absolutely correct that, you need to get government involved. If, for example, you want to start a new undergraduate course, or HND in additive manufacturing, you cannot do that alone without, the appropriate, authorities, either the NUC or whatever else it is, sanctioning it. So that is why, our research, the research I did with colleagues, looked at the triple elite model of technological leapfrogging. You need a synergy of government, of industry stakeholders, and of university and, higher education sector. Absolutely. I don't know what Dr. Oloketuyi has to say. Is there any progress? Have you made any inroad? Is government interested? Are you working with them? Are they interested in working with you in your institution? I think you are muted still. You're muted. You need to mute.
Thank you very much. My experience in Yaba College of Technology, I remember about 2 years ago, Lagos State Chamber of Commerce. I happened to be in their technology forum. they were discussing how they can help the higher institutions of learning to, in one way or the other. And during the discussion, I made a proposal to them that it would be better for the Chamber of Commerce to buy 3D printer for some institutions, especially in Lagos there. And that's my suggestion was accepted. The first 3D printer that Yaba College of Technology has, which is behind me as I'm talking to you, was donated by Lagos State Chamber of Commerce to Yaba College of Technology. Another one was given to Unilag, another one to Leicester Tech and Lagos State University, about 5 institutions. So, and ever it was that one actually that encouraged me to purchase my own, because I was thinking that well, this machine has been given to us, but because of epileptic power supply in our college, I said to myself that the machine might not be used at all. So I bought my own and I was able to use that. And even from there, I've been able to do some works, which if time permits me, I would just like to show the slides. So what I'm just trying to say that corporate bodies, governments, they have a lot of roles to play to encourage the technology in our institutions of learning. And the only way we can even entice the governments is to probably introduce a 3D competition among the institutions of learning, and actually have projects that solve specific problems in the society. And I know that when the government representatives are invited, they will be highly interested in whatever is produced, and from there might be policy change towards embracing 3D printing. So my suggestion is let there be annual competition in different formats to woo the governments and the policymakers to 3D printing. And I think this will work. Thank you.
Yes, thank you very much. Thank you. I am mindful of the time because it's 5 o'clock now. So in the interest of time, we would go through, your research and what you've done, Dr. Oloketuyi. But I would like to say a big thank you to everyone present. And indeed, we've learned some things on 3D printing today. I in particular, I've learned, the various types of 3D printing, and obviously the importance of it, low capital investment, waste management is minimum as well. And of course, allowing rapid prototyping of new products and services, which is great. So I'd very much love to thank Dr. Oloketuyi for, being with us today, and Dr. Seun Kolade as well for organizing this session. If you have any further questions, I mean, an email is welcome. We'll put the emails up. But yes, before we go, Dr. Oloketuyi, if you could, briefly share your research areas. And yes, we would share the videos and the slides, wouldn't we, Dr. Kolade, going forward with everybody.
Yeah, absolutely. I think you have a slide about some of your products that you want to share briefly. If you have that now, we can use that to round up the session.
Yes.
If it's just two minutes, how long is it?
Yes. Dr. Oloketuyi, I think you're muted. You're muted.
Okay, thank you. This is the first 3D print I made from from the demo file of my Ender 3 version 2 3D printer, and it came out fine. And after that, I produced this slider crank mechanism. I teach mechanics of machine in Yaba College of Technology. I teach a linkage mechanism, and this is one of the laboratory apparatus that is required to study the the car engine mechanism. This is a slider crank mechanism. A student can use it to perform experiments, measure angle, angle of the crank and the slider distance, get the velocity as a good result. This is a bladeless fan project. I tried to design the configuration using SolidWorks, and it came out fine. Then I developed this one recently because of petroleum scarcity. I noticed that people normally use mouth to siphon petrol, and which is very dangerous. I designed this device to simply use a large syringe to cause vacuum to be along the pipeline, and you see the water was flowing out of the device. It's a very simple device. Somebody has even requested me to design one for him, which I'm working on presently. Then this one is this one I converted jerry can to watering can to wet garden. You can see the head. I designed this head and printed it on my 3D printer. This air ventilator, I converted undercord AC blower to a centrifugal fan that can be used to ventilate a room or do one thing or the other. I printed that black plastic section. I printed it. It took me about 30 hours to print the components. Then this is a spraying bottle. Hypothetically, I designed it using Bernoulli's equation in fluid mechanics, and it came out fine. So those are the things I can show for now because of our time. Thank you.
Yes.
Excellent work. Really great stuff. Really well done, well done, well done. Brilliant
yes,
stuff.
well done. Thank you very much for sharing that with us. And thank you all for attending this session. And we hope to see you all in our future webinar series as well. Thank you very much.
Yeah, thank you very much, everyone. And we will be sharing the link. So to the session, we'll be sharing it across the various networks, and you have access to it. Thank you once again, and enjoy the rest of the day.
Thank you. Thank you. I see my dad. Hello, Dad.